All right, let's get started here with 6.1, law of sines. So we're going to have the law of sines, and 6.2 is the law of cosines. So we'll start here today with just the law of sines. All right, so chapter 4, we did all sorts of good stuff with right triangles, sine and cosine and tangent, right? Chapter 4 and 5, all sorts of trigonometric stuff, but they all had to be for right triangles. So chapter 6, we're going to start introducing what do we do if we don't have right triangles, okay? No right angles here, oblique triangles. So you'll see this triangle here. It's a triangle, 3 sides, but no right angles. Just a reminder how we label these. Angles are capital letters, and the side lengths are the lowercase same letter that matches up across the triangle. So angle A, you look across the triangle, you have side little a. All right, to solve an oblique triangle, what that means is we get all 3 angles and all 3 sides. So if we're asked to solve an oblique triangle, we want to be able to get all 3 angles and all 3 sides. To do that, we need to know 3 things to start, okay? And that can be 2 angles and a side, so that's angle, angle, side, or angle, side, angle. You'll remember this from geometry. If we know 2 sides and the angle opposite them, so like we know angle C and angle B, and then the opposite angle A, side, side angle. That's one option. Option 3, we know all 3 sides. Option 4, we got side, angle, side, 2 sides, and the angle in between them. Okay, so 4 different situations, 4 scenarios. The first one, law of sines, and the second one we can do, the first 2 we can do with law of sines. If we have 2 angles and we have 1 side, we can do law of sines, or if we have 2 sides and an angle that's not in between them. For instance, angles C and B, and sides A and C, and angle A or angle C. 2 sides and the angle not between them. All right, here's the law of sines. Take a second, copy this down, and you only need 2 of this. Side A over sine A equals either side B over sine B or C over sine C. All right, you can match any 2 of these 3 up together to solve. All right, and if we want to, if it helps us, we can always do the reciprocal. We can flip this over and do sine A on top with side length A in the denominator. All right, so let's give this a shot. For triangle in figure 6.2, we know angle C, we know angle B, and we know side length B. Let's find everything else. So here's what we're going to do. I know angle B and side B. So I'm going to start with that. If we remember from the law of sines, sine B over B equals something, but let's just start with that. Sine of 29 over side length B, which is 28, equals, now I know angle C. So let's go for sine C over the side length C. So sine of 102 over side length C. Okay? And so we're going to plug this into our calculator. Let me grab that. And so we can do these all in one step here. This is going to be 28. Oh, let me make sure I'm in degrees. I am. 28 times the sine of 102. And then we'll end up dividing by the sine of 29. And that'll give us C. So C is 56.49. What does it say? It doesn't tell us what to round to, so we'll go 2 decimal places if we're not told otherwise. So what do we say? 56.49. And that's in feet. All right. Now the next one over here, we can do this again. Sine of 29 over 28. Now we could at this point do sine of 102 over 56.49, but since we rounded to get that 56.49, it's better to stick with the original, the exact values. So sine of, and we don't know A yet, but we can figure out A pretty easily because there's 180 degrees in a triangle. Take away angle C, that's 78. Take away angle B, and that's, what do we got here? 69 minus 20 is 49. So we're left with 49 degrees in here. So we know that big A is 49 degrees. That's the easiest thing to find. Sine of 49 degrees all over side length A. And let's figure this out. And it's going to be 28 times the sine of 49 divided by the sine of 29, and 43.59. For little a. 43.59 feet. All right, so that's how you would solve that sort of triangle. Remember, when it says to solve the triangle, find all the remaining lengths and angles. So try problem number 5. Okay, let's see the same thing here. A pole tilts towards the sun at an 8-degree angle from the vertical. So you can see here we're listing by 8 degrees, which makes this angle here not 90, but 98. And it casts a 22-foot shadow. So we have a nice shadow here. The angle of elevation, remember, angle of elevation is from the ground rotating up, is 43. How tall is the pole? So we're trying to find side A here. Okay? All right, so if we want to find side A, and we know angle A, we're in business. So let's start with that. We've got A over sine of A equals, now do we have a match anywhere here? We've got 22 feet, so I can put the 22 here, but that's from side C. So we need to know angle C up here. All right, so we're going to have to say 180 minus 43 gets us 137. And let's then take away the 98 from here. So that's 129 minus 90 is 39 degrees. So this will be sine of 39. And let's plug this into our calculator. So we've got 22 times sine of 43 divided by the sine of 39. 23.84. So that's how tall our tree is. Telephone pole. Yep, that's how tall the pole would be. 23.84 feet. All right, so try exercise 45. Okay, so now we're going to talk about the ambiguous case, SSA. And it's written this way because otherwise if you flipped it around the other way, it wouldn't get past the censors in writing the book. But that's how you can remember that if it's a side-side angle triangle, that it's kind of a tricky one and one that you have to think about for a second. It's not the really easy one. So examples 1 and 2, you saw 2 angles and a side, determine a unique triangle. If you have an SSA, there's 3 possible situations that you can get. No triangle, 1 exact triangle, or possibly 2 different triangles could occur. Okay? So if we have something, and it's kind of hard to think about the 2, so we'll think about that in a second. But let's start with the none. If we have a triangle where A, side length A, okay, is shorter than the height, then if we see this, if we tried to swing it down, it would never touch the ground here, and it would never complete our triangle. So the way we find our height is with this formula right here. The height is B sine of A. Plug that in. That's the height. If side A is smaller than that, no triangles exist. If it's equal to it exactly, then there's 1 triangle. Okay? All right. So then, if H is bigger than A, okay, if H is bigger than A, then we've got some possibilities over here, and we can go through these cases. I don't like to memorize these cases. I like to go through the process and see which one is which. You can memorize this if it helps. There's some situations here. Okay, the one thing where we have 2 is think about where A is nice and long. If it's sitting right here, right, if this is an acute angle, we would have 1 triangle, the acute triangle. But if you swung A out, like it was pivoted from here and swung out and landed here, then we'd have a nice obtuse triangle. Okay, so there's 2 possible triangles that exist if side length A is long enough to make that happen. And we'll see how that works here in a second. All right, so for the triangle here, find the remaining sides and the angles. So this is, we can visualize this. This is an angle, angle, side, side. 2 sides with an angle not in between them. All right, so if we look at this one, we go back to our chart, we compare A and B, and there's only one triangle here. The other way that we could do this, and here's what we're going to do. We're going to start right away. We're going to do the law of sines. So we're going to say sine of 42 over 22, right? Those are the angle inside that matches up, equals 12, that's the side length, over the sine of B. Okay? Now we're going to just figure out for B here. Go into our calculator. We're going to do sine of 42. We're going to times it by 12. We're going to divide by 22. And that'll give us sine B. So sine B equals 0.36. How are we going to end up with B? We got to do the inverse sine of 0.36. My calculator doesn't go up and grab it. Yours should. So press up and grab that. Type out a few decimal places here. I get 21.41 degrees. So B equals 21.41 degrees. Here's what you're going to do to figure out if there's one or two solutions, not memorizing this. If you memorize this, that's fine. There's just going to be one solution. Here's the other way to do it. Or put in 180 degrees minus whatever you got here. 180 degrees minus 21.41 degrees. That ends up being 158.59 degrees. All right, and then you have to ask yourselves, if this angle here is 158.59 degrees, this angle already is 42 degrees over here. If you put those together, that's bigger than 180 degrees. Can't have that in a triangle. All right, so this one couldn't be a second angle. We know that B is 21.41 degrees. All right, and then from there we need to find our last angle. We can subtract from 180, so 180 minus 42 is 138. Minus 21.41 is, what do we have here? 116. That's right, 0.59. So we figured out angle C, 116.59 degrees. And then we'll use our law of sines again to find side C. So now we know that, let's go back to our original, sine of 42 over 22 equals the sine of 116.59 over C. And I'm going to go ahead and flip that over because it's easier when the variable you want is on top. So 22 over sine of 42 equals C over the sine of 116.59. Let's grab our calculator, punch that in, and see what we get. So 22 times sine, what was this, of 116.59 and divided by the sine of 42. 29.40 would be the side length for C. All right, your turn on problem 25. All right, so now let's show that there is no triangle that can exist here. All right, there's no solution. So we've got angle A is 85, B is 25, A is 15. All right, so one thing that we could do is we could say B sine A, and that'll give us H. So in this case, we're going to say 25 times the sine of 85. Let's punch that in. And that's 24 degrees. Sorry, that's a height, so that's 24.9. All right, and 24.9 is bigger than our length here of 15. So if 24.9 is bigger than 15, then H is bigger than A. We're not going to have a solution. Here's the way you can figure that out without having to memorize that. Let's do our law of sines here. We know that sine of 85, that's angle A, over 15 equals sine of B, don't know that angle, over 25. All right, and so let's go ahead and plug that in. We've got sine of 85 times 25 divided by 15. 1.66. We're going to do the inverse sine of 1.66, and you're going to get an error when we do this. The reason why is that sine is opposite over hypotenuse. The opposite divided by hypotenuse can't be bigger than 1. The hypotenuse has to be the biggest side of your triangle. So just by plugging it in, if you get the sine bigger than 1, not going to work. So we know that there's no triangle here. All right, so you're up on 27. See if there's a triangle. If it exists, figure out everything. All right, so let's talk about the two solution case. Find two triangles for which A equals 12, B is 31, and A is 20.5. So let's draw ourselves a nice triangle. And we've got, that's A, and this is 20.5 down here at A. We'll call this B, and that's 31 down here. And side C we don't know anything about at all. All right, so let's go ahead and get started. We're going to figure out the sine of B over 31 is equal to the sine of 20.5 over 12. We'll plug this in, solve for B. Sine of 20.5 divided by 12. Nope, sorry. Times first. Times 31 divided by 12. And we'll do the inverse sine of that. And we get 64.8 degrees. Just going to round it to 1 decimal place here. So, B equals 64.8 degrees. Or 180 minus that, which equals 120, 116, 115.2 degrees. Is that possible with 20? If we added another 20 degrees, would we be less than 180? Yes, we would. So now we have a case where we might have two triangles. Here's triangle 1. This is triangle 2. All right, so now we're going to have to figure out for the rest of them. For angle C and side C, two solutions for both. Angle C is the easy one, because we're just going to subtract from 180. 180 minus 20.5 is 159.5. Okay? And then from there, 159.5 minus 64.8. That's a 7. That's a 4. And that's a 9. 94.7. Or 159.5 minus the other angle, 115.2. That's a 3, that's a 4, that's a 4, 44.3. Okay? And then we have to go ahead and find side C. So let's go with our original here, sine of 20.5, sorry, over 12 equals the sine of 94.7 over C. We have to set it up over here for the other possible angle C. Sine of 20.5 over 12 equals the sine of 44.3 over little c. Let's solve them both. First one here, we've got 12 times the sine of 94.7 divided by the sine of 20.5, and we get 34.15, so 34.2, and we're calling that little c1. And let's go back in there and get little c2. So we're going to have 12 times sine of 44.3, and we'll divide that by the sine of 20.5. 23.93. Little c2. All right, so we ended up with two distinct answers. One for angles B, C, and side C. Okay, one each for all of those. Your turn. Work it all the way out for this triangle. Okay, now last thing that we're going to do here in 6-1, we have a formula to find the area of a triangle. If we know a couple things here. The formula, if you know that the formula is half the base times the height, we know if you draw it like this that the base is side C, so we'll replace it with that. And then we know from that other formula the height is B sine A. Put it together, here's your formula. 1/2 base times height turns into 1/2 two sides times the sine of the angle in between them. Okay, so AB sine the other angle. If we know two sides and the other angle, we can find the area. Okay, and if the angle is 90 degrees, the sine of 90 is 1, so that just turns into your base times height, the formula you've always known. Okay, all right, so let's wrap things up here with an area problem. We've got a nice triangle here, lengths of 90 and 52, and the angle in between them is 102 degrees. So we go to our formula, 1/2 90, one side times the other side times the sine of the included angle. AB sine C, right? From back here, AB sine the included angle. So where's our good friend the calculator? Half of 90 is 45 times 52 times the sine of 102. 2288.86 is the area of that triangle. Your turn on 39. All right, and then let's do an application here. Is this the last one? That is. Last one here. All right, a bridge is to be built across the small lake from a gazebo. So here's our bridge we're building, okay, to a dock. The bearing from the gazebo to the dock is south. So remember, bearing, we're going to point south from the gazebo. We're going to look south and then spin west 41 degrees. So this angle in here is 41. From a tree 100 meters from the gazebo, the bearing to the gazebo and the dock are south 74 east. So if I look straight south from the tree and spun 74, I'd look at the gazebo. If I was at the tree and looked south and then spun 28 degrees, I'd look at the dock. All right? Find this distance from the gazebo to the dock. All right? So, first things first, if we're going to find this side over here, let's call this side A. Then we're going to need to know the sine of angle A over here, which would be 74 minus 28. 74 minus 28, what do we got here? 66 minus 20 is 46, so sine of 46 equals, we need to know another side. We know 100 over here, which means we would need to know this angle in here. Okay, so let's see if we can figure out what these angles are going to be. And here's where you're going to figure it out. We're going to extend these type of problems. Extend your right triangles. If this is 41 and this is 90, then this is 49. If this is 28 and this is 90, then we can subtract 90 minus 28 is 62. 180 degrees makes up a half circle. 180 minus 62 is 118. 118 minus 49 is 109 minus 40, which would be 69. And so this angle in here is 69 degrees. So we can do over sine of 69. And let's finish that up with the calculator. We've got 100 times the sine of 46 divided by the sine of 69. Bingo bango, 77 is the distance from the gazebo to the dock. Your turn. Wrap this thing up. Oh, look at that. I skipped your problem. I did the problem for you. Go back and do example 7 then. I skipped this one. Your answer's in the book. See if you can do it on your own. I apologize. I did the problem in the book. That's all right. One for you to try if you go back and do the example. Okay? And see if you make sure you refresh up on bearing as well. We're going to need that. All right, that's it for 6-1. Any questions? I will see you in class.